Hello, I was watching this video today that Gary Wybenga had put out a few weeks ago, and he made what looked like a fairly compelling argument about the angular size and all of that stuff. And I decided I was going to try to analyze this to see if this really was the case. And if you haven't watched it, I'll give you a very quick synopsis of it. His argument is that when you look up at the top of this building here, when you're this close, it appears like the angular size of, let's say, maybe the top or the top floor or the top two floors. It looks like the angular size here is smaller than the top would be if you were further back, and this certainly does on the surface look like it's a little bit larger. So what I did was I took a screenshot of that particular part of the video and I duplicated the layer and I moved it so that this one would be in the same location as this one. And I added a separate layer, which is a reference line. I started off by making the bottom string a little bit thicker than the top, but you can see that this black reference line, top and bottom, pretty much line up with this farther rubber band. And so now if I put the other one on, you can see I did a reasonably good job, I think, of rotating the bottom rubber band so that it kind of lined up here and here. It looks like this was not nearly as stretched or as tensioned as this one, and so it was allowed what looks to me, the bottom of this rubber band seemed to bow in a little bit like this. That's what it looks like to me. But his claim that as you move further back, the angular size appears larger is obviously not true. And I wasn't quite satisfied with that. So what I did was I created a spreadsheet that kind of simulated his setup, and I'll leave the link to this spreadsheet in the description below, so go chase that down. If you look at his video, he had one that appeared to be kind of almost the height of one of these floors of this building he was looking at. Then he had several more that were much further back, and I kind of figured that this was about, if this is 5 meters, this one might be 5, 10, 15, 25, maybe 30, 35, maybe 40. So if we do that, we could say this one is 40, this one was 30, and this one is 5. And these pretty much don't mean much of anything. These are just the observer height. I also added the capability where you could pretend to go up, let's say maybe to the 3rd floor, or rather to the 30th meter, which would be, let's say, maybe the 6th floor. And what that would do is it would give you kind of a line of sight to the 10th, 9th, 8th, 7th, so on and so forth, all the way to the 1st. This one represents the angle up or the angle down. So if you're at 30 meters and you're looking at the 1st floor, which is 5 meters above ground, you should have a vertical angle or an angle down of 32 degrees, and the 10th floor would be an angle up of 26. As you move closer, these angles get much larger. And then what I did was the difference in the angle column represents this, and this one is the 10th minus the 9th. This one is the 9th minus the 8th, and this one is the 2nd minus the 1st. So there's only 9 floor angle deltas rather than the 10 floors. This would be the equivalent of 1, 2, 8, 9. And so what does this tell us? If we go back down to the ground and we look at the difference in the angle between the 9th and the 10th floor, we have 2.97 degrees at 40 meters, 2.7 degrees at 30 meters, and 0.62 degrees difference at 5 meters. If, however, we come back to his diagram, the peg that he has it on would be the equivalent of looking up at the first, second, between the third and the fifth floor, which would be somewhere around here. And as you can see, the difference between the third and the second floor at 30 meters is 8.13 degrees. However, the difference between the two floors when you're at 40 meters is 6.5 degrees. So what does that really mean? Well, when you look at the difference in the angle between two consecutive floors, like what Gary Wybenga was trying to show, the difference between two individual floors does seem to matter depending on the angle that you are dealing with, the closer that you get to the object. However, this does not explain what we really see in reality, because if we're looking at a ship that has a mast of 50 meters above the ground out at sea, we're probably looking at a ship that is closer to maybe 18 kilometers away. And so what does it look like now? That looks awfully flat to me. 1.59154914 something. This one is 15486, 15479. We're getting down into the seventh and eighth decimal place of an angle. In fact, we are dealing well below 1 arc second, because 1 arc second would be 1/3600th of a degree. But Gary's logic is actually in reverse. His argument is that the further you are away from the object, the difference in angular resolution between the lower objects is smaller than the difference in the angular resolution of the top objects, and so the bottom would disappear first. But what happens if you're in a high-rise on one side of a lake on a flat Earth, looking across the lake to a high-rise of equal height on the other side of the lake? If you were on the ground floor looking up, according to Gary's video, and the bottom disappearing first due to a more shallow angle or whatever, then the opposite should be true if you go to the top floor looking across the lake to the other high-rise. According to Gary's theory, the top of the building should be hidden behind angular compression and Rayleigh criterion, and we should see the bottom of the high-rise. But that's not what we see at all. Gaining height does not cut the top off in order to see the bottom. What can I conclude from that? I would conclude that Gary's theory is inaccurate and he has to come up with a new theory. And I would suggest, as a hint, he starts looking into a spherical Earth. Thank you for watching. If you liked the video, give it a thumbs up, comment below, share, all that stuff. If you don't like it, you can give it a thumbs down. I don't care too much. It helps the YouTube algorithm. Comment below as well. You know what to do. Thank you for watching. That's going to be it for this one, and I'm going to see you again in another video soon enough. So bye for now.